Mr. Bowman here. Today's learning objective is in green, and we are learning to use Pythagoras' theory to show if triangles are right-angled or not. So these questions are going to be a little bit different, and I'm going to actually jot down the first question just to show you what I mean by that. So here's our triangle. So notice I didn't say it was a right-angled triangle, and it has dimensions of 8, 15, and 17. So just emphasizing this type of question, you're given all of the sides. So we're not trying to calculate anything. What we're trying to do is we're speculating. So in this slot here, is it a right angle? Is it not a right angle? We're not quite sure. We're trying to use Pythagoras' theory to show that it is a right angle or not a right angle. So the way we do this type of question is we're going to jot down our formula a squared plus b squared is equal to c squared. We're going to substitute in our value. So opposite the hypotenuse is the long side of the triangle. It would be c, and we've got b and a floating around on the other sides. So if this is a right angle triangle, we're going to evaluate what a squared and b squared is, add them together. We're going to compare that to what c squared is. If it's a right angle triangle, you're going to expect the same number to come up twice. If it is not a right angle triangle, different numbers are going to come up. So let's get into that. A is going to be 15 squared plus 8 squared. I wrote down a 6 for some reason, but 8 squared. That should equal to 17 squared. It might not, but it should. That's going to be 15 squared is 225. 8 squared is 64. That there is going to be equal to 289. Let's add these together. Does that get us to 289? It does. 289 equals 289. The fact that we're getting the same number coming up twice on the left-hand side and the right-hand side tells us a squared and b squared is equal to c squared. So therefore, a squared plus b squared is equal to c squared, which means, so therefore again, it is a right-angled triangle. Right-angled triangle. If these numbers, 289 equals 289, were different numbers, maybe one number was different to the other, that would suggest that it's not a right angle triangle. We're going to finish up with one of those examples, so it'll be a short video. So let's have a look at our second example. I've got a right angle triangle, and the dimensions, I've got our triangle. I'm actually trying to show if it's a right angle triangle. 7, 8, and 12. Your first step, jot down your formula. A squared plus b squared should be equal to c squared. Let's go ahead and calculate what a squared and b squared is. We'll do the same with c squared, see if we've got a right angle triangle. So the longer side of the triangle, that should be the hypotenuse. That should be opposite that right angle, if it is a right angle. And the other two sides, 8 might be a, b might be 7. So we're now going to substitute that in. So 8 squared plus 7 squared should be equal to 12 squared. So we've got 64 plus 49 equals 149. 64 plus 49 is 113. And that equals to 144. Now these two numbers here, they are different. And that tells us, so therefore, a squared plus b squared does not equal to c squared, and therefore not a right-angled triangle. So guys, short video again. Hopefully you found this useful. Hopefully you can say, yes, I know how to compare right angle and non-right angle triangles. I know how to show them using Pythagoras' theory. Thanks so much for watching, guys. Now let's get into lots of practice now.